This is a question on carbonyl chemistry. It also includes some nomenclature and isomerism. 4 parts, A to D, 8 marks in total. So pause, try, and then review. Here's parts A and B. Part C. And part D. So if we take a look at part A, we are given the structural formula. And we need to come up with the name for it, the IUPAC name. So I've gone through to see how many carbons there are, and we can see that that is 6. So the name is going to be based on hex. There are notable bonds there, so it's hexan, and there is a nitrile group within it, which is a CN. Now we've also got an OH. We can't use the normal suffix ol because we've got the suffix nitrile and that takes priority. So we're going to have to use the prefix. So we're going to use hydroxy. It's on the second carbon, so it's 2-hydroxy. At the moment, hexan nitrile, but you can do all of this hard work and you don't yet have the mark. The reason is you have to have the E. I call it the magic E. In nitriles, you have to have the E directly before the nitrile suffix, otherwise you will not be credited. Okay, on to part B, describing how you would distinguish between separate samples. Straightforward factual recall here. In optical isomerism, we use plane polarized light, and when you shine plane polarized light through the sample, one of the enantiomers will rotate the light clockwise, the other will rotate it anti-clockwise. Moving on to part C, about why this reaction produces a racemic mixture. Quite a common question. You are looking at the fact that the carbonyl group within your compound is planar. You've got to be really careful here not to say that it's a planar molecule. It isn't. There are bond angles that would show that there's tetrahedral components to it, for example. So we can only talk in terms of the carbonyl group. The rest of it is fairly standard. It's a relatively straightforward and common response. It can be attacked from either side, gets you the second mark, and the fact that that can happen with equal probability gets you the third mark. Finally, moving on to part D, we're doing a reaction between KCN followed by dilute acid, but we're doing that with an isomer of the aldehyde that has been produced. Now, if it's an isomer of the aldehyde, we're immediately thinking it's going to be a ketone. I'm also thinking that if it's not going to show stereoisomerism, that's more likely if I can have a level of symmetry within the compound. So I'm going to go for pentan 3-one. The CN- is going to come in and attack. There's a whole mechanism that goes in place there, but that will take us to this compound. Our nitrile group is attached to the third carbon. We've got an OH on the other side of it. But crucially, the reason that this does not show stereoisomerism is that there is not a single chiral centre. If we go from left to right, the first carbon has 3 H's, so it doesn't have 4 different groups. Second carbon has 2 H's. And the fourth has 2 H's, and the fifth has 3 H's. So they are definitely not chiral. They are not asymmetric carbon atoms. Carbon in the middle has got a CN, it's got an OH, but it has 2 ethyl groups. If all 4 of the groups are not different, then there's no optical isomerism.